Hi, welcome to episode 4 of the video series titled Stratum V2 Explained. Today we're going to talk about Stratum Reference Implementation, or SRI for short. So first of all, as usual, acknowledgements. This series is based on Gabriele Vernetti's Master Thesis at Politecnico Di Torino, titled Stratum V2, the next generation protocol for Bitcoin pool mining. Highly recommend that you just go on GitHub and check it out. There's a PDF file there, really fun to read. So Stratum Reference Implementation is a full open source community based implementation of the Stratum V2 protocol specifications. And the team started in 2020, and it is composed by independent developers majorly funded by individual grants. The project is supported by many companies involved in mining operations such as Brains, Foundry, and Galaxy Digital. And in addition to them, other entities are also involved such as BitMEX, Human Rights Foundation, Spiral, and OpenSats. Nowadays, most of the implementation work has been done, but there are still some open discussions related to protocol specifications, such as role structure, noise encryption, job negotiation, declaration, and there's also an ongoing effort for fixing bugs and getting feedback from the community. So how does SRI work? There's this notion of roles, and they're all contained in the roles folder of the Rust codebase. So maybe we can just type in github.com/stratum/stratum, and here we can find this directory here called roles. And that's where we have different cargo crates that implement each different role. So first one is the pool, right? Represents the pool server. Can open any kind of communication channels with downstream roles, which are usually proxies or mining devices. So this is the SRI pool crate, and that's where all the pool magic happens. Mining device represents a conceptual mining device that's written in Rust and still compatible with the SRI stack. So it can connect to a Stratum V2 pool or mining proxy and performs mining operations. This is mostly used for testing. There is no aim for profitability here, since, well, this all mining happens here via CPU. So we can find that here on task utils, and you're gonna find a mining device which speaks SV2. There's also an SV1 mining device that sort of emulates a legacy device that will connect while speaking Stratum V1. Proxy. It acts as an intermediary between the mining devices and the pool. So it receives mining requests from multiple devices, aggregates them, and forwards them to the pool. It can open group or extended channels with upstream and standard channels with downstream. So upstream here means the pool, downstream means the devices. And we can find the mining proxy crate here. Translator proxy. It is responsible for translating communication between SV1 mining devices and an SV2 pool or an SV2 mining proxy. So it enables SV1 devices to interact with SV2 based mining infrastructure, bridging the gap between older or legacy SV1 protocol and SV2. And we can open extended channels with upstream also, where upstream here would be a pool or yet another proxy, but this time an SV2 proxy. Job declarators. So these are roles which can be pool side and miner side, but they can also be run by any third parties. They're connected to a template provider, and in this way they're able to receive and validate custom block templates. They are the roles needed to implement the so-called job declaration protocol, and they can further distribute jobs to a mining proxy via the job distribution protocol. So we have the job declarator server, which is a role that happens on the pool side, and it is in charge of allocating mining job tokens needed by the job declarator client to create custom jobs to work on. The server is also the entity responsible for pool side block propagation in case of valid blocks found by miners connected to the pool that are using the job declaration protocol. We also have the job declarator client, which is the role that happens on the miner side, and it is in charge of creating new mining jobs from templates received by the template provider. It declares custom jobs to the JDS, to the server, in order to start working on them. The job declarator client is also responsible for putting in action the pool fallback mechanism, automatically switching to backup pools in case of declared custom jobs are refused by one specific job declarator server. As a solution of last resort, it is also able to switch to solo mining until new, safe, and desirable pools appear in the market, so that the miner can go back to pool mining. So coming back to the roles, I think I forgot to show the translator crate. So this is it. But we also have the JD client and the JD server, which are the roles that we just looked at. They're still missing, JD server is still missing a README file. JD client has a README file. And yeah, so these are the roles that you're gonna find on the SRI codebase. And we also have the template provider, which enables the extraction of transactions from Bitcoin nodes. This way, miners are now able to create custom block templates and negotiate their use with the job negotiator or the job declarator via the job declaration protocol. You're not going to find a directory here on this roles directory. That's because the template provider is a Bitcoin D or a Bitcoin Core fork. It still hasn't been merged to upstream Bitcoin Core, so we're still using a fork by yours. And you can find it here, and if you look for this branch called 2023-11 SV2 poll. This is the Bitcoin Core that the Stratum team is using for testing, at least at the time of recording this video. Hopefully sometime in the future either this fork or some other fork is going to be merged to Bitcoin Core, and it's going to be able to use Stratum V2 features by default. SRI configurations. So thanks to all these different roles and subprotocols, Stratum V2 can be used in many different mining contexts, right? You can sort of do different combinations of the roles and arrive to different setups depending on how the pool wishes to operate or how the miner wishes to operate. The SRI working group defined 4 main possible configurations, which can be the most probable, more realistic use cases, and we're gonna look into them now. So configuration A, before Stratum V2, transaction sets to be mined in the next block were selected by pools. We've talked about this a lot already. So with this Stratum V2 configuration, they're selected by individual miners instead. So the network becomes more censorship resistant. And also in this configuration, we're assuming that miners already have Stratum V2 compatible firmware. So the miners connect to a proxy. And there's the job declarator role, where individual miners are able to pick up their transactions locally, extracting them from their own local template provider, and then declaring them to the pool. So here's a visual representation of configuration A. There's multiple mining devices running SV2 firmware here. All of them connect to a proxy, and this proxy is being run on the miner side, so it's probably sitting in some machine inside a mining farm, as well as the job declarator client and a Bitcoin D acting as template provider. So everything to the left of my mouse is on the miner side. Everything on the right to my mouse is on the pool side. So there's the pool server that's running there, as well as the job declarator server that is also connected to a Bitcoin D that acts as a template provider. So what's happening here is that the proxy aggregates all the shares that are coming from different mining devices, and it sends it upstream towards the pool. And the job declarators, the client and the server, they keep doing this negotiation to make sure that the shares that are being submitted by the miner, they're in agreement with the template rules that the pool is establishing. And for the miner, as soon as, if for some reason the pool starts to reject their templates, the miner can just switch pools, just go to a different pool. So we have a little bit more efficiency in terms of hash rate market efficiency on this configuration. So let's look into configuration B. Here, we're also assuming that mining devices are running SV2 firmware, so they can connect to just a SV2 proxy. And but on this configuration, the miner is not running a job declarator client. So the templates are sort of imposed by the SV2 pool, just like it was done on SV1. But still, this setup still provides an improvement in relationship to SV1 to the extent that there's still some security and performance improvements happening that are brought by SV2. So here's a visual representation of this setup. I have the different mining devices here. They're just connecting to the proxy, and then the proxy is sending the shares upstream towards the pool. Very similar to what happened in SV1, but the main difference here is the fact that this connection is encrypted. So if there were a man in the middle here sniffing this connection and trying to steal shares, they wouldn't be able to do that because the connection is encrypted. Another difference is the fact that all these connections, they're happening in binary format. So that saves up a lot of bandwidth resources. So this communication is way more efficient than how it happened on Stratum V1. So let's look into configuration C. With this setup, mining devices don't need to run SV2 compatible firmware. Translator proxy is used to translate the SV1 messages coming from the mining devices into SV2 messages that are going to the SV2 pool. In this case, the translator proxy is not configured to use a template provider. So templates are still being selected by the pool, but there's still a difference in comparison to Stratum V1, as we're going to see here in the visual representation. So here we have a translator proxy this time, right? And the mining devices are running SV1. They connect to the proxy using SV1. So this connection here on this side is a little bit inefficient. Things are happening here. They're not binary encoded. They're plain text. There's no encryption. So hopefully this is a network environment that's shielded from man-in-the-middle attacks. But then the connection between the proxy and the pool is still an SV2 connection. So we still have a lot of benefits from it. Like I just said before in the previous configuration, this is encrypted, this is binary, therefore it's better. We're still lacking here the ability for the miner to pick their templates. So yeah, the miner is still somewhat subject to the pools imposing block templates, but well, maybe the miner is okay with that, and that's fine. Finally, configuration D, very similar to configuration C, but we just add the template provider to the miner side. So the miner runs the translator proxy plus a job declarator client, and the pool has a job declarator server. So the miner is able to build their own block templates. So here's a visual representation. Mining devices running SV1 firmware, connections SV1, everything goes to proxy, translator proxy this time, and it sends it upstream. Job declarator on both sides, the client, the server, template provider on both sides, and the miner is picking which transactions go into the block, And if the pool doesn't like that, the miner can just go to another pool. So let's change subjects a little bit. Now let's talk a bit about the SRI benchmarking suite. This is an effort that's being led by Gabriele Vernetti as well, the guy that wrote that master thesis I showed you in the beginning of this video. So a major mining protocol update like the one proposed by SRI is very sensitive, mainly because there's mining operations are big. They're basically industrial scale operations nowadays. So in order to encourage SV2 wide adoption, the SRI team believes that it's important to have a complete and precise evaluation and measurements, so we're able to quantify the enhancements that are brought by Stratum V2. And so a benchmarking suite is needed for that, so that mining industry professionals and the broader market, they can easily understand every possible configuration that's permitted by SRI, and they're gonna be able to measure themselves the potential benefits in terms of efficiency and consequently the profitability of their operations. So yeah, the main purpose of benchmarking is to demonstrate with precise measurements all the performance improvements brought by SV2. So that's it for this episode. On the next episode, we're gonna do a little SRI tutorial. We're gonna look into some of the prerequisites. We're gonna set up a configuration D setup like this one. I chose this one because most mining hardware nowadays still SV1, so I think it makes sense to educate the community on how to connect SV1 hardware to an SV2 pool. That's what we're gonna be doing there. We're gonna do some mining with both with the CPU miner as well as with an ASIC. So yeah, that's it. Thanks a lot for your attention.